This is a key to Worksheet 4.3, Part 4. And in Part 4, you're using the properties of logarithms. And so notice that the number 2, you're going to use the properties of logarithms to expand these log expressions. And in Part 3, you're going to use the properties of logarithms to condense. Okay, so in number 1, though, you're asked to use the base change formula in your calculator to approximate the following to 4 decimal places. All right, so if you recall your calculator, to use your calculator only has, if you remember, log and natural log. So the log function here is base 10, and obviously the natural log, remember, is base e. So this is your common logarithm, this is your natural logarithm. So if you notice that in number 1, the base is neither 10 nor is it a natural logarithm, it's the base e. So the base is 5. But there is a formula that says that you can change any base to another base, regardless of what the base is, as long as it's positive and it's not 1. Okay, so basically the change of base formula says this. So if you want to change the base to a different base, let's say base a, then you would say the log of m, base a, the new base, so this is your new base, divided by the log of the original base, okay, with the new base, okay? So the log of m base b becomes, you can write it as this, and you can go from any base, from this base to any base. It can be base 2, base 2.7, base 3, base 4.6, whatever you want to. But keep in mind that if you're using your calculator, then you really want to use a logarithm, the common logarithm or the natural logarithm. Okay? So in number 1, basically what you're going to do is this. You're going to say, all right, so I want to use a calculator. So this is base 5. So I'm going to change this. I'm going to change log of 7 base 5 to a new base. And so let's say the common logarithm. All right, so you can say, all right, so that's going to be the log of 7 divided by the log of the base, which is 5. And use your calculator, and you're done. Someone else could have said, I'm going to use base e. All right, so then you're going to say the natural logarithm. So you can say the natural log of 7 divided by the natural log of 5. And it doesn't matter what base you use, but if you can use your calculator, you want to use either the common logarithm or the natural logarithm. And notice, regardless of which one you use, you get the same answer. So if you said the log of 7, make sure you close that parentheses though, divided by the log of 5, close the parentheses, press equal, and it says to 4 decimal places, you would say, so that's approximately equal to 1.2091, 1.2091 to 4 decimal places. So remember, since this is 5 or bigger, then the 0 becomes 1. All right, so the answer is, oh, and if you said natural log, so you'd say natural log. You get the same thing, 7 divided by natural log of 5. Close the parentheses, press equal, and notice you get the same thing. All right, so it didn't matter whether you use the common logarithm or the natural logarithm. So 1.2091. Okay, now to do 2 and 3, you have to remember your properties for logarithms. So remember to expand or condense, you have to use these properties. So there's product rule, quotient rule, power rule. And so the product rule says that if you're taking the log of a product, then you can expand this. So expanding means to go from one logarithm to multiple logarithms, to 2 or more. Or in this case, expanding would mean to take the product, the power rather, and write as a product. But when you're dealing with product or quotient rule, expanding means to write as 2 or more logarithms. So the log of a product becomes the sum of 2 logs, the logs of the factors. And notice the bases stay the same. Make sure you write the base, whatever the base is. So if the base is 3, then these you got to write 3. Because if you don't have a base, it's understood to be a common logarithm. And then the log of a quotient becomes, that should be subtraction. Sorry, that's subtraction. So the difference of 2 logarithms, right? So now remember, the order matters when you subtract. So it's the log of the numerator minus the log of the denominator, okay? And then Make sure you write your bases. And then the power rule says that you can take, when you have the log of some expression raised to a power, you can take that exponent and write it as a factor, so write as a product. So you see where you take the exponent p and you write it out here. Okay? All right, so that's the properties of logarithms that you're going to use with numbers 2 and 3. So if you look at number 2, you have in 2a, that's what you have. In 2a, you have the log base 5 of this product, z squared times the square root of x. Okay? Now, so if you look at this, you got to remember some things from the lesson. You got to remember that you really need to write the square root of x as a rational exponent. All right. Secondly, you got to be careful. So some of you are going to want to say, well, I'm going to use the power rule first. Well, you can't. The only time you can use the power rule, so use the power rule first if if you have something like this, log base b of some expression raised to a power. All right, so this whole expression, whatever you're taking the log of, this whole expression has to be raised to that power. So you see, you're taking the log of this, right? But this whole expression is not being raised to the second power, it's being raised to the first power. All right, so don't use the power rule first. So if you notice though, at some point you will use a power rule, at some point you will use the product rule because this says z squared times the square root of x, and then you're going to use the power rule again because remember the square root of x is x to the 1/2. So what I would do first is this. I would go ahead and use the I would go ahead and change the square root of x to a rational exponent. You don't have to do this first, but it does help. It does help you to not forget to do that later on. So that's this. Y'all agree? All right. Now let's use the power rule. So I'm going to use the product rule. The product rule. So we use the product rule. So this becomes the log of z squared base 5 plus the log of x to the 1/2 base 5, right? Okay, so the log of z squared base 5 plus the log of x to the 1/2 base 5. All right, now I can use the power rule because I'm taking the log and here's my expression and it's being raised to the second power. Here's my expression, it's being raised to the 1/2 power. All right, so now I'm going to use the power rule. So the power rule is going to be next. So I get 2 log of z base 5 plus 1/2 log of x base 5. Just make sure it looks like a base. And there's your answer. Okay, so that's all you do. All right, so remember you have to use the properties as much as possible. All right, so that's number 2a. So 2a, the answer is 2 log of z base 5 plus 1/2 log of x base 5. All right. So let's look at 2b now. So 2b says this. 2b says you want to expand the log of x to the 4th divided by y, all raised to the 6th power. All right. So if you look at this, notice several things. Notice that I am, and this is log, okay, so this is log base 10, so that's common logarithm. Okay, so notice that I do have a quotient, right? And I do have a power and I have another power, correct? Okay, so you can do several things. What you could do first is notice that I have the log of some expression raised to power, so if I want to, I can use a power rule first. So let's go and use a power rule first. So this becomes 6 log of x to the 4th divided by y. Okay, so I use the power rule. All right, now I'm going to use the quotient rule. Don't use the power rule again because if you do, then you're going to mess up when you expand this even further. So you have to use the quotient rule first, then come back and finish off with the power rule. So the quotient rule then you're going to write this as a difference. So now what I would do is I would cover this coefficient for right now and just look at this part here. Okay, just look at this part here. So this part is the log of x to the fourth minus the log of y. And all of that is being multiplied by 6. All right? Okay, now cover this 6 again, and now I can use the power rule on this part. So this becomes 4, in brackets I have 4 log of x minus log of y, right? Okay? Don't forget that's being multiplied by 6 though, so keep bringing that 6 down. Now let's go ahead and get rid of the bracket. All right, so you need to do that also. You need to clear as much of these grouping symbols as possible. And so I get 6 times 4 is 24 log of x minus, and then 6 times log of y is 6 log y. Okay? All right, now I want to go back and look at that same problem again. Let's look at that same problem again. You have the log of x to the fourth divided by y raised to 6th power. Okay, so I just want to remind you about something you learned in the previous course. So if I were to cover up this right here, and let's say in a previous course you wanted to simplify this expression. So if you recall in a previous course, and I'm going to go ahead and kind of rewrite it here. So you have x to the fourth divided by y, all raised to the 6th power. All right, so I just went ahead and just rewrote it here. So remember in a previous course, one of your properties for exponents. So one of your properties for exponents said this: if you have x to the a raised to the b power, right? Then when you have a power raised to power, you can multiply those exponents. That becomes x to the a times b. All right. So if you look at this, I can, and here I have a quotient, but I take the numerator, raise to that power, so x to the fourth raised to the 6th becomes x to the 24th, right? And then y to the first raised to the 6th becomes y to the 6th. So if I want to, I can rewrite this as this. All right, so that becomes now, so that becomes the log of x to the 24th divided by y to the 6th. All right. Now, many students just go ahead and do this because some students always forget about the denominator. So they'll get the numerator, they'll say x to the 24th, but then forget about the fact that the denominator is also being raised to the 6th power, and they'll just put y, and then they mess up. So they'll just resort to just using the power rule first. Okay, so if we continue on, this becomes now the quotient rule. So again, you can't use the power rule yet because you're taking the log of this expression was being raised to the 1st power, not the 24th. So this becomes the log of x to the 24th minus the log of y to the 6th. And then notice now you can use the power rule. So the power rule, this becomes 24 log of x minus 6 log of y. And that's what you had here, right? Okay, so either approach is fine. Just here you have to remember some things from previous course as well. Okay. All right, so it's 2b. So the answer for 2b is 24 log of x minus 6 log of y. Okay, now 2c you have this. So in 2c you have the natural log of e to the 5th times x squared. All right, so it's very similar to 2a. So remember when we did 2a, we had here, you have a log of a product, right? Okay, so it's very similar, except you got to, in this case, you'll see what's going to happen. You're going to have to use something from a previous lesson as well. So I'm going to use a product rule first. So that's going to become the natural log of e to the 5th plus the natural log of x squared, right? Okay. All right, so now I'm going to, so I use the product rule. That's what I did here. All right, now I'm going to use the power rule. The power rule. And so the power rule, I get 5 times the natural log of e plus 2 times the natural log of x. All right, now, some of you are going to leave the answer like this, and that's not quite correct. All right, you did some pretty good work here, but you got to remember you need to simplify as much as possible. So what do you remember about the natural log of e? What's that equal to? Well, the natural log of e is 1 because remember the base here is understood to be e, so e to what power is e? E to the first. So it becomes 5 times 1 plus 2 natural log of x, and so the answer is 5 plus 2 natural log of x. Now don't make the mistake and say that's 7 natural log of x. So mistake is this. Some students, you go through this quickly and you forget some things. So mistake is to say that 5 plus 2 natural log of x equals 7 natural log of x. That's not true. All right. So notice that if this was going to equal 7 natural log of x, then you better have 5 natural log of x. All right. What is true is this. What is true is this, that 5 natural log of x plus 2 natural log of x equals 7 natural log of x. All right. So if you're going to get 7 natural log of x, then you better have a natural log of x in both terms. Okay. All right. So don't say that's a 7. Don't say 5 plus 2 is 7. It just remember this. It's the same idea. You're not going to say, remember that 5 plus 2y is not 7y, right? Okay, so is not 7y. All right, so same idea. Those are not like terms. Those are not like terms. All right, so not like terms. You can't combine. Not like terms. Can't combine. All right. Okay, so it's 2c. So 2c, the answer is 5 plus 2 natural log of x. All right, now let's look at 2d. So in 2d, you have the log of a quotient. All right, so in 2d, you have the log of a quotient, and the quotient is 100 divided by x. Now notice that there's no log there, no base there, so this would be 10, so that's your common logarithm. All right, so we use the quotient rule, so it becomes the log of 100 minus the log of x. Now, you need to go further as much as possible. So remember, what's the log of 100? Well, the base is 10, so 10 to what power is 100? 2. So that's 2. So it becomes 2 minus the log of x. And those are not like terms, so you're done. This is your answer. All right, so 2d, the answer is 2 minus the log of x. All right, now number 3, you're condensing. So basically what you mean is this. So remember, to expand, you go from one logarithm to 2 or more when you're dealing with product and quotient. And for the power rule, to expand means you take your power and you write as a product. Okay? So condensing means you go from 2 or more to one logarithm. And also, your final answer, you need to make sure that the number in front of that log, that coefficient, is a 1. Okay? All right. So let's look at number 3a. So in 3a, you have this. All right, you have so 3a, you have 3 log of 2 base x plus log of 3 base x. Okay? All right, so if you're going to write this as one logarithm, all right, if you're going to write this as one logarithm, also keep in mind that in order to condense, notice one thing, that these coefficients here are 1s. Coefficients here are 1s. Well, this is the power rule, but for the product and quotient, the coefficients are 1s. Okay? Now what I want you to think about is this. This coefficient is not a 1, so the first thing you're going to do is you're going to use the power rule. So use the power rule first. Okay? So this becomes, so now what that means is this. Let me go ahead and rewrite this over. Okay, what that means is this, that you're going to take this factor and you're going to write it as a product. I'm sorry, as a power, excuse me, as an exponent. Okay? So use the power rule. So this becomes the log base x of 2 to the third, okay, plus the log of 3 base x. All right, so remember, you're going to use the power rule first because you want the coefficient of log expression to be 1. All right, so in other words, you want this right here to be a 1. Okay, that's what you want. You want that to be a 1. So that was a 3. So you had to rewrite this using one of your properties, and that was the power rule. Okay, now what you want to do is simplify this as much as possible. 2 cubed is 8, so it becomes the log of 8 base x plus the log of 3 base x. All right, so now, remember, condensing means to write what you started out with as one logarithm with a coefficient of 1. Okay, so notice that these numbers out here, the coefficients is 1, this coefficient is 1. Okay, so now, do y'all see that this, I can use the product rule? So now that becomes the log base x of this product, 8 times 3. All right, and 8 times 3 is 24, so I get the log base x of 24. All right, so that was 3a. So notice that the first thing you have to do in this case is use the power rule so we can get this coefficient here to be a 1. And then we just simplified along the way. So 2 cubed is 8, and then I use the product rule right here. All right, and then we simplified 8 times 3 is 24. Okay, so it's 3a. So 3a, the answer is log of 24 base x. All right, now 3b, that's what we have in 3b. So in 3b, we have 3 log of a base 3 minus 2 log of b base 3. All right, so 3 log of a base 3 minus 2 log of b base 3. Now, don't make the mistake and do this. So remember, so you see that difference here, and so you're going to think quotient. You can't use a quotient rule first, because remember, in order to use a quotient rule first, this number out here has to be 1, and this has to be a 1 as well. So when you see that subtraction, you need to make sure that's a 1. Okay, so notice that that's not a 1 right here. That's a 2 for your difference. Okay, so we have to use the power rule again. So remember, use the power rule first whenever you need to, because you want that coefficient in front of the log to be a 1. All right, so in this case, I'm going to use the power rule. And so this becomes the log of a cubed base 3 minus the log of b squared base 3. All right. Now I can use the quotient rule. Now, remember right here we had 2 cubed and you have a cubed? Well, the reason why we went further because you know what 2 cubed is. So you can simplify that. You can rewrite that. 2 cubed is 8. Well, you don't know what a is, so just leave it as a cubed. All right, so now I can use the quotient rule, so that becomes, and notice that the reason is because this is a 1, and you're subtracting 1 log base 3 of b squared. So it becomes a log of a cubed divided by b squared base 3. Don't forget your base. And so that's the answer for 3b. So 3b, the answer is, for 3b, the answer is log base 3 of a cubed divided by b squared. All right, now in C, we have this. So in C, we have 2 log of x plus 3 log of y minus 5 log of z. So I have 3 logarithms. All right, so if I'm going to condense, though, if you're going to condense, you got to make sure that these numbers in front of those logs, those coefficients, are 1s. So in this case, none of them are 1. That's a 2. You're adding a 3, and you're 3 times the log, and you're subtracting a 5 times the log, right? So we're going to use the power rule first. Power rule. So that becomes the log of x squared plus the log of y cubed minus the log of z to the 5th. Okay? All right, now we're adding and subtracting. So remember, the order of operations still applies here. So I'm going to add first. I'm going to do the addition first. So this is the product rule. So you do that first. So according to the product rule, this becomes the log of x squared y cubed, right? Minus the log of z to the fifth. So I use the product rule. And now I'm going to use, since I'm subtracting, now I'm going to use the quotient rule. So that becomes the log. So I'm using the quotient rule. So that first expression is your numerator. And that second argument here is your denominator. And that's your answer. So we use the quotient rule. Okay? All right, so that's the answer to 3C. So 3C, the answer is log of, the numerator is x squared y cubed, the denominator is z to the fifth. Okay? And don't forget, it helps if you put that in parentheses. You didn't have to, but you got to be careful how you write it. So I would just go ahead and put these in parentheses. I didn't need that in parentheses because it's just a number. Okay, so that is the key to worksheet 4.3, part